Okay, so for this video, we're going to get into some of the really critical parts of algebra, some of the really important skills that you need, which are working with exponents and polynomials. So just as a recap, some of our kind of important exponent rules. One is that if I'm multiplying two bases together and those bases are the same, then I can actually add their exponents. Okay. Another is that if I'm dividing two of the same base together, I can subtract their exponents. And when I raise a power to a power, we actually multiply those exponents together. So those are our three really basic exponent rules. Another thing we want to keep in mind is that if I have a product of some sort and I'm raising a whole product to a power, then that exponent actually gets distributed over multiplication here. So in this case, when I have a times b to the x power, that's going to result in a to the x times b to the x. So just an example of how some of these operations work. The first example I have is x to the fifth times x to the third. I'm multiplying and the bases are the same, so that's going to give me x to the 5 plus 3 power, which means I'm going to have x to the 8th power as my result. In the second example, letter B, we have 2 times the product 3x squared. Now what you want to notice is that this squared is going to get distributed to everything inside the parentheses, but it's not going to get distributed to the 2 because that's outside. So we have 2 times, and then everything inside the parentheses is going to get squared, so that's going to give me 9x squared. And then I can actually do this multiplication. 2 times 9 is going to give me 18, so 18x squared. In the third example, letter C, again, I have a product being raised to a power. So this 4th power is going to get distributed over the multiplication here, which means I'm going to have an x to the 3rd power raised to the 4th and a y to the 4th. But now this power to a power that I have in the x, I know that we have to multiply those exponents together. So this is going to give me x to the 12th times y to the 4th. And finally, I have this quotient here. Okay, 3x to the 3rd y to the 6th divided by 12x to the 5th y squared. So what we want to keep in mind is that we are dividing. And so, for example, this 3 over 12, it is going to just kind of reduce to 1 over 4. Okay, so we'll leave the 4 in the denominator there. Now, as we look at the rest of the pieces, I have x's, x to the 3rd in the numerator and x to the 5th in the denominator. But the x to the 3rd in the numerator is actually smaller, so when we subtract those exponents, we're going to be left with an x squared in the denominator because that's where my larger quantity was. X squared. And then finally with the y's, I have a y to the 6th and a y squared, and we're going to subtract those exponents, and it's going to leave me a y to the 4th. And again, the y to the 6th, which was in the numerator, was the larger quantity, which is why the result lands in the numerator of the fraction. Polynomials. So for polynomials, when we're adding and subtracting them, we want to make sure that we're always combining like terms. And just as a reminder, like terms means that I have the same variables and they're being raised to the same exponents. So when I combine like terms, for example, in this first problem, 3q to the 3rd and then 1q to the 3rd, okay, we do have sort of an imaginary coefficient here of 1. I want to add together those two terms, and what that means is that I'm going to add together their coefficients. So that's going to result in 4q to the 3rd. Going down, we do kind of want to proceed in decreasing exponent order. So the next thing I want to address is my 4q squared, but it doesn't have any like terms, so there's nothing to combine with. It's just going to come down and be a 4q squared here. And then finally, I have this minus 5 and minus 7. So my two integer terms can get added together as well. So it's going to be a minus 12. And so there's my sum. In the next example, I just have a difference instead of a sum. So what we want to remember is that first I'm going to distribute this negative sign, but just to the second parentheses. We can kind of imagine this as being multiplied by a negative 1. So I distribute into the second set of parentheses. So first set of parentheses stays the way it is, and then the second gets distributed negative 1. So this is going to be negative 2x squared plus 5ax minus 7x. And now I can go ahead and combine my like terms. So I've got a 5x squared and a minus 2x squared. That's going to give me 3x squared. If I'm looking for more like terms, I have a minus 5x and a minus 7x. That's going to give me minus 12x. But now if I look at my last two terms, they're actually not like terms. I have a 3a squared and a plus 5ax. And those guys can't combine at all. They don't have anything like terms to combine with. So I'm just going to add those on to the end here. Plus 3a squared plus 5ax. All right, so finally, when we multiply and divide monomials and polynomials, basically general rules, I want to simplify coefficients and keep in mind those rules of exponents. If I happen to have two binomials, okay, two-term polynomials at the same time, we want to FOIL. So in this first example, we're raising a product to a power just like we did before, so I'm going to distribute that third power to everything inside the parentheses. So I have a negative x squared to the third, that's going to give me negative x to the sixth, y to the third, and then a z to the fourth to the third, that's going to give me z to the 12th. So nice and straightforward, that one. B, I have a product of two monomials. There's no addition or subtraction, which means that each expression is only one term. And so I just want to multiply. So I'm going to multiply my coefficient. 7 times 4 gives me 28. I have an r times r to the third. That's going to give me r to the fourth when we add those exponents. And a t squared times t. So that's going to give me t to the third, again, adding the exponents. Now, in example C, I have two terms in the numerator because I can see that we've got this kind of plus sign here, which means it's going to separate two separate terms. And I'm dividing by negative 4a squared b to the third. So that means that each term in the numerator has to get divided by that denominator. So sometimes I kind of like to write that out separately so I don't forget to divide both terms of the numerator. So each of these two terms is going to get divided by a negative 4a squared b to the third. Negative 4a squared b to the third. So simplifying each of those terms now, sorry it's a bit messy, I've got negative 8 and negative 4, that's going to reduce to a 2. And then a to the fifth divided by a squared, that's going to give me a to the third. And b to the eighth divided by b to the third, we subtract those exponents, we get b to the fifth. So that's that first term. Second term, the b to the thirds are going to cancel, the a to the seconds are going to cancel, and all we're left with is a 2 over negative 4, which reduces to negative 1/2. Okay, almost done. Another distributing of an exponent over multiplication, so everything inside here is going to get raised to the third power. So 3 to the third is 27, x to the fourth to the third power is going to be x to the 12th, and y to the 9th to the third power, so we multiply those exponents, we get y to the 27th. Sorry. Okay, nearly there. Letter E, again, just kind of basic simplifying. 7 over 35 is going to reduce to 1 over 5. X to the fourth over x squared is going to give me x squared, 2 x's in the numerator. And a y over y to the third is going to leave 2 y's, y squared in the denominator. Okay, just quickly kind of subtracting exponents. And the more you do this, the better you'll get. Lastly, I have a monomial outside of set of parentheses. Okay, so in here we've got a trinomial because I've got two addition subtraction signs, so this is going to split us up into 3 separate terms. And I want to distribute the monomial outside to each term. So first I'm going to multiply 8x squared y times the 5x. That's going to give me 40x to the third y. And then I'm going to distribute to the second term here. So my coefficients, 8 times 2 gives me 16 times x squared times times y to the third when we add those exponents together. And then finally to the third term here, so we're going to have a minus 24 x squared y. So there's my whole product. Okay, so again, tomorrow in class you're going to be working on some more examples of these, and we'll get into this a little bit more.